The third serial protocol that the Arduino Uno implements is the SPI protocol. SPI stands for Serial Peripheral Interface Bus. So there's SPI, Serial Peripheral Interface Bus. So with SPI you can have very fast serial full duplex communication with an external device, unlike the I2C, which, because it only has one data wire, it only allows for information to flow, for data to flow in one direction at a time. So with SPI, communication is much faster and it is full duplex. So devices like this one here, like this is a graphics display, implement this interface. So if I turn it over, you'll see that we've got a bunch of wires, especially DC, CS, MOSI, clock. These are the pins that implement the SPI protocol on this device. So we've got 4 wires instead of just the 2 that the I2C interface implements. With the SPI protocol, a connection between the Arduino and the external device, like this screen for example, happens by connecting all these 4 wires to the device. So we've got the 2 data lines. So I'll make the two green lines to represent data. So we've got data going one direction and then data going the other direction. That's how we have full duplex. Then we also have a clock line, which I will draw as blue. So blue is our clock. And I'll make an orange line called the slave select. So SS is slave select. Blue is SCK, which is a clock. And the 2 green lines are MOSI and MISO, which basically convey data. MOSI is master output or master out, slave in. And you can probably guess that MISO is the opposite, is master in, slave out. Now what happens if you want to have multiple SPI devices connected? Let's say that you have perhaps an SD card reader that allows you to store data readings from a sensor onto an SD card in order to implement something like a data logger. So what you do in this case is that you can share the data lines. You can also share the clock line. But then, as far as the slave select is concerned, you need to use another pin, another digital pin on your Arduino and implement a different, separate, independent slave select line. So the idea here is that your Arduino will be able to talk to an SPI device one at a time. Although you can have multiple such devices, only one of those devices can be communicating with the Arduino at one time. So you use the orange lines here to turn on or off one of the SPI slaves. So for example, if you want to get data or if you want to send data to your screen, then you need to put this orange line to high, logical high, and any other orange line going to other SPI devices to logical low. This way you disable any other device and just enable your screen, the device that you want to send data to. If you want to write a new reading from a sensor to your SD card, this device here, then you do the opposite. You will bring this orange line up to high in order to enable this device and take over its SPI channel, and then you need to take all the other orange lines to low in order to disable them and disable their SPI interfaces. There are other configurations by which you can use the SPI interface, but this is the most common one, especially most common that you find on the Arduino. If you're curious about the details of the SPI, then go and have a look at this article on Wikipedia. It's packed with information about this protocol. Just like with I2C, there is an SPI library that ships with the Arduino IDE that makes communication between the Arduino and SPI devices very, very easy. So we don't really need to dig into the details of the implementation of the SPI protocol on the device at the hardware level. All that is taken care of by the very easy to use SPI library. In this lecture, I gave you an overview of the 3 communications protocols that you can find on the Arduino that make it very easy to communicate with external devices and peripherals, and even other Arduinos and a computer. So these are the UART serial interface, the I2C interface, and the SPI interface. And the Arduino ships with one of each. If you need to connect additional serial devices to your Arduino, then you can implement additional UART interfaces in software inside a sketch using a library called Software Serial. I'm going to show you examples of implementation of each of these interfaces in other lectures further down in this course. Thanks for watching. If you'd like to learn more, check out my Arduino Step-by-Step Getting Started and Arduino Step-by-Step Getting Serious courses on the Tech Explorations School. There, I help you develop basic and more advanced Arduino skills, including how to write your own programs, how to use all sorts of sensors and actuators, and how to create your own gadgets. You may also be interested in my project courses, where you get deep into the development of wheeled robots, remote-controlled cars, and drones. Please use the coupon code in the description below this video to get a YouTube exclusive discount to my courses. See you there!